All right, guys, so here we are working some more with the trig values of the special angles. You were kind of in quadrant, or did sine, cosine, and tangent yesterday a lot and did the quadrantals, but we're going to mix them all up. So let's see if you can, from scratch, without looking at anything, do not look, no cheating, write in terms of x and y. So write the ratio in terms of x and y, those 6 trig functions. So stop the video, see if you can do it. Okay, here we go. So sine is y, cosine is x, tangent is y over x, cosecant is flip y, secant is flip x, and cotangent is x over y. You have to have that memorized. There is nothing I can do for you if you can't memorize that cosine is x and sine is y and what secant is and what tangent. Y'all, we can't help you. You have to have that memorized. So that is super, super important of you knowing that. Now, as we did yesterday, you're certainly welcome. I mean, if we do as we're doing these problems, notice the kind of way that we did it yesterday. We thought about where the angle was. We thought about what its ordered pair was. And then we went back to these formulas and picked the right one. That's perfectly fine and wonderful. So let's just do an example that way. So let's do the cosecant of 120. So if I know we have that chart, and I'll do that in a second, but just like we did yesterday, here's the idea. Okay, with cosecant of 120, cosecant is, so hard to mark this on, is right there. 120, not cosecant is right there, 120 is right there. Now think of its ordered pair. Its ordered pair is negative in the x, short, and long in the y. Do you agree? Okay. Now, the cosecant is what? Now that's where once you get the ordered pair, you're going back to these things right here. Cosecant is 1 over y, or in other words, flip the y coordinate. So you're going to look at this and you're going to flip it. 2 over square root 3. But remember, we do want you to rationalize. So you should be good at that by now. If I multiply by the square root of 3, I get 2 square root of 3 over 3. And that's the cosecant of 120. Now, I want to show you, I mean, what this chart is. Y'all, it's not, oh my gosh, we're changing the whole system. You have to figure out the system that you like. I do the system what I just did. I circle, I think of the coordinate, and then I do what I need to do. Some people like to organize, like, I mean, hopefully by now you realize, you know what, I don't have to memorize the whole unit circle. I kind of have to know quadrant 1, and then I just make sure I put the positive and negative right. Well, what this chart does is it helps you organize those values. You guys, watch how cool this is. Okay, are you ready? Let's do it. So remember that old, y'all don't probably remember the song, but remember Michael Jackson. I can't believe I'm singing on camera, but you know, it's easy as ABC, 1, 2, 3, whatever that song is. Okay, this is easy as ABC, 1, 2, 3. You ready? So when you're filling out this chart, notice across the top we have cosine, sine, and tangent. If you're like, how do they go? They're in alphabetical order. Cosine, sine, tangent. So CST. So they're in alphabetical order. Down this way, think of it kind of in the quadrant. Okay, as you think about it, we have 60 kind of on top. That's the biggest, and then 45 and 30. So they're kind of going in descending order like they do. Okay, the cosines, watch how quickly that I can kind of fill out this chart, if you will. Think of the cosines as you go from 60, the x-coordinate, it's getting bigger, right? So we're going to go, it's easy as ABC, 1, 2, 3. And the sines are getting smaller. So the sines are going to be 1, 2, 3. So it's easy as 1, 2, 3, 1, 2, 3. You kind of fill it out that way, kind of go down. So 1, 2, 3, and then go back up 1, 2, 3. Now you're like, that's not the cosine and sine. You're right. But get that, and then here's the cool thing. All of these guys, you're going to put a square root. on top, and in the bottom of the fraction, what's in the bottom of all these fractions? They're all 2's. So 2, 2, 2, 2, 2, 2. And remember I said to put square roots on top. Now I'm not going to put a square root on 1 because I know that the square root of 1 is 1. So don't do that. Don't put square root of 1, put 1. Looky there. Y'all, I just wrote the sines and cosines. So if you like to organize it in a chart, that's awesome. As far as the tangents, just remember what tangent is. Tangent, remember, is sine over cosine. So again, you can't see me doing this, but with my fingers, I'm covering up these, and I'm looking here, then here. So square root of 3 over 1, which of course is square root of 3. This one's going to be 1. This is going to be 1 over square root 3, which rationalized. Hopefully you go, that's square root of 3 over 3. So if you like to organize your stuff in a chart, that is a very quick way of getting that information down. And then you're just kind of looking at a chart. So if you like that way better, that's fine. But you still, here's my thing with the chart, and what I've kind of found is that a lot of people mess up the sign, S-I-G-N, the positive, negative, because they just look at the chart and they forget to do the positives and negatives. That's why I prefer kind of looking at the circle, marking it right in the ordered pair. So that's my method of preference. But listen, I want you to get them right. So you have to figure out what is best for you. Okay, if you're in quadrant 1, yeah, the chart's awesome because the answers are sitting right in front of you. But when you're outside of quadrant 1, you've got to remember the sign. So I like thinking of the circle first because then I don't forget to do that. So that's the way I'm going to attack the rest of these problems. So the tangent of 7 pi over 6. Friends, the tangent of 7 pi over 6 is, well, here's 7 pi over 6. The ordered pair would be negative square root of 3 over 2, negative 1/2 x, y. I cover up these guys, and I do y over x. And so I get, again, negative 1 over negative square root of 3. The negatives cancel, and so I get square root of 3 over 3. And you say, wait a minute, that's the same thing as I got with that pi over 6. Interesting. Okay, let's do secant of 45. Well, the secant of 45, I'm hoping that you go, well, gosh, I already know. That's the square root of 2. I'm in quadrant 1, so I know the ordered pair is square root of 2 over 2, square root of 2 over 2. With secant, I'm going to look at the x-coordinate, and then I'm going to flip it. So remember, when I flip that, I get this. And if you watched the video from yesterday, you'd say, you know what? This one I'm going to kind of memorize. That when I flip square root of 2 over 2, what do I really get? I really get the square root of 2. All right, cosecant of 5 pi over 4. Cosecant of 5 pi over 4, here's 5 pi over 4. The y-coordinate, why did I say the y-coordinate? Because it's cosecant, that's the flip of the y. So again, you're going to get faster in this. I know I'm writing all these steps and you're like, oh my gosh, that's a lot of writing. Eventually, guys, you're going to be so fast at this that you're going to call that out, and you're going to know it. And that's what eventually, when you get to calculus next year, you can't go, oh, let me write down my chart and figure this out. No, it should be like, oh, cosecant of 5 pi over 4, boom, I know it. So you've got to get to that point. Now, obviously, you're not at that point in this moment, and that's why I'm writing all this out to show you your thought process. But eventually, you start understanding things, and it makes sense to you, and you can get them faster. So the cosecant of 5 pi over 4, I'm going to flip the y-coordinate. Well, I know flipping doesn't change the sign, so it's negative. We just said that, so I get negative square root of 2. Secant of 90, well, that ordered pair is 0, 1. Oh, what did we talk about the secant of 90? That means I would flip the x-coordinate. So I'm flipping 0 over 1. That gives me 1 over 0. Then I have undefined. Cotangent of 2 pi over 3. What's the ordered pair of 2 pi over 3? The ordered pair of 2 pi over 3 is going to be negative x and positive y. Okay, careful. First of all, I know if I divide a negative by a positive, my answer is going to be negative, so I know my answer is going to be negative. I'm going to cover up the 2's. Cotangent, I do x over y, so negative 1 over square root of 3. Rationalized is negative 3 square root of 3. Pi over 3. And what I'm hoping that you see from this, especially when you do your homework, is that, wait a minute, so you're telling me all the signs of the 60 degrees or pi over 3's, all the signs are going to be square root 3 over 2. It's just a matter if it's positive or negative. Yes. All of the tangents of the pi over 4's or the 45's are going to be 1. It's just a matter if it's positive or negative. Yes. All the secants of the pi over 6's are going to be the flip of this number, because I said secant. It's just a matter of positive or negative. Yes. And so that's what I'm hoping, where you're going, okay, this unit circle thing is not that bad. I just have to memorize quadrant 1, know where the angle is, and I can get the value. So why don't you try to do the last few? Now remember, you're going, wait, you gave me the hard ones. Sort of, because they're over 2 pi. But remember, don't freak out when you see something that's over 2 pi. What are you going to do? You're just going to say, psh, nothing but a thing. 17 pi over 6. If I subtracted 2 pi, because that's over 2 pi, what's the best look of that? Well, that would be 12 pi over 6, because that would be 2 pi. So that would give me 5 pi over 6. So this question is really saying, what is the tangent of 5 pi over 6? That's what it's saying. 5 pi over 6 is here. Let's write the ordered pair. Long in the x, short in the y. I'm going left. I'm going negative x, positive y. So there's my ordered pair. Tangent is y over x. I cover up those. I do 1 over negative square root of 3. I think about rationalizing, and there's my answer. Secant of 480. Well, let's just subtract 360, why don't we? That says 120. So that question really is saying, what is the secant of 120 degrees? That's here. Ordered pair, negative 1/2 square root 3 over 2. What am I going to look at? Well, secant is the flip of the x. What is the flip of negative 1/2? Negative 2. Tangent of 7 pi over 2. Again, let's do coterminal angles. 7 pi over 2 minus 4 pi over 2, which is 2 pi, gives me 3 pi over 2. That's down there. Ordered pair, 0, negative 1. What is tangent? Tangent is y over x. So I have negative 1 over 0, so that is undefined. And 660, well, let's subtract 360. We made it fairly easy for you. 300. So that's really asking the cosecant of 300 degrees. Well, where is 300? Well, that's 270. 300 is going to be right there. What's the ordered pair? 1/2 negative square root 3 over 2, positive x, negative y. And so cosecant is 1 over y, so that means flip this guy. Negative 2 over square root 3. Let's rationalize, and we get that. So that's what you're going to be doing a lot of practice on. So let's think for a second, again, just visually, of determine which trig ratios are positive in each quadrant. Now let's do the main 3, because again, I'm going to think sine, cosine, and tangent. Because the reciprocal functions follow their mate, okay? Again, flipping something doesn't change the sign. So let's just talk about sine, cosine, and tangent. Y'all, again, Yes, there's a lot of memorization in this unit, but if you understand, the memorizing is not hard. Okay, if I ask I don't know what grade you learned to plot points, but it was young. If I ask you to write an ordered pair in quadrant 1 and just tell me the sign of a point that was in quadrant 1, you would say, as far as positives and negatives, well, it would be a positive x and a positive y, correct? What would it be in quadrant 2? It would be a negative x and a positive y. Quadrant 3, they'd both be negative. Quadrant 4, positive, and then a negative. Now, is that something new to you? No, that is nothing new. So now the only part that you have to get is like, okay, really, that's cosine, that's sine, and when I divide, I get tangent. So in quadrant 1, everything, all are positive because positive x, positive y, when I divide, a positive divided by a positive, I get positive. In quadrant 2, which one of these is going to be positive? Well, negative x, that's cosine, positive y, so sine is going to be positive, right? What about tangent? Tangent's not going to be positive because you're dividing a positive by a negative. So that's going to be negative. So in quadrant 2, sine is positive. Let's look at quadrant 3. Is sine positive? Nope. You have negative, negative. So sine and cosine are both negative. What about tangent? Well, if you divide two negatives, what do you get? You get a positive. So the tangent is positive in quadrant 3. In quadrant 4, cosine is positive. Is sine positive? Nope, because you have the negative. When you divide, you get negative. So those are the ones of the 3 that are positive. And again, I want to say, when I say sine is positive, I also mean that cosecant is positive. Because remember, the reciprocals match their mate. So again, this just kind of helps you. I'm just giving you a visual. Again, to me, if you think about the circle, it makes sense. If you're going up for the y's, the sign is positive and down is negative. For x's, left and right. So it's just another tool to help you. And you can remember to always study trig carefully. A-S-T-C. A-S-T-C. So if you like to think of the what's positive in each quadrant, that will help you remember that. Again, it's not something I necessarily memorize because I just go back to this. And that's something I already know, and I can then figure out the question that way. So I like that. But again, I've got 150 students. So you have to kind of do it in the way that you kind of tell all sorts of methods and you pick out yours. So it said, let theta be an angle in standard position. In which quadrants can theta be located under the given positions? Sine and cosine have the same sign. Well, here's the thing. This is why I like thinking the positive negatives. Guys, if you look at the positives and negatives, look at those and go, okay, in which quadrants are the x coordinate and the y coordinate the same sign? Well, that's quadrants 1 and 3. Remember, the quadrants are numbered this way. Don't miss a problem because you don't know how the quadrants are numbered. Okay, 1, 2, 3, 4. So in quadrants 1 and 3, sine and cosine have the same sign. Okay, cotangent and cosine have opposite signs. Okay, let's just think of that. Let's just go quadrant by quadrant. Cotangent and cosine. Now, really, when it says cotangent, could I not think of tangent? Because again, tangent is, a reciprocal function is just not going to change the sign. So when I see those reciprocal functions, I just go to one of these guys. So let's look. Quadrant 1. Cosine is positive, and tangent would be positive. So those aren't opposite. Let's look in quadrant 2. Cosine is negative. Okay, what would the tangent be in quadrant 2? Well, if you divide by a negative by a positive, you also get a negative. Are those opposite signs? No, those are the same signs, so it's not that. In quadrant 3, cosine is negative. but tangent would be positive. Those are opposite, so quadrant 3. In quadrant 4, cosine is positive, and tangent would be negative, so those are opposite, so we get 3 and 4. So there you go. Last few. See if you can do those. Remember, the reciprocal functions are the same as their partners. So when it says secant is less than 0, let's just do this. Wouldn't that be cosine is less than 0? So for these, I think what I like to do is I like doing this. Okay, where is cosine negative? Friends, cosine is x. Think of on the quadrants, where would the x-coordinate be negative? That would be in here and in here. So this is where cosine is negative. Now, where is tangent positive? Well, tangent is positive when the signs of the x and y are the same. So that would be in quadrants 1 and 3. Well, it says and. So which one did I check twice? That's quadrant 3. Last one. Where is tangent negative? That's when the signs would be opposite. So that's 2 and 4. Where is cosecant positive? So cosecant is the flip of sine. So where is sine positive? That's 1 and 2. Where did I check twice? Quadrant 2. So work on that, and we'll see you mañana. Peace out.